Hello everyone, welcome to the discussions of the past year questions. This video we shall take a look at the further mechanics paper 3, October-November 2022, paper 31. Let's take a look at the first questions. A particle of mass 2 kg is attached to one end of a light inextensible string of length 0.6 meter. The other end of the string is attached to a fixed point on a smooth horizontal surface. The particle is moving in a circular path on the surface. The tension in the string is 20 Newton. So this is the diagram. So it will be moving in a circular motion like this. And the tension given is 20 meter. And the mass over here is 20 kg, 2 kg. The mass is 2 kg. Okay. So what we need to do is that the question is looking for how many revolutions of the particle makes per minute. So what we can do is that at first we resolve the forces horizontally, and we get the D is equal to the mr omega square. In order to get the number of revolutions, we just need to find the angular speed omega. So D is 20, then m is 2. The radius r is 0.6. Omega you do not know. So from here, you just use your calculator, press it, you will get the answer of a square root of 50/3. Or we can make it become decimal. So this is not the final answer. So I will leave the answer in a few more decimal places. So it will be 4.0825 radian per second. But this one is only the angular speed. We want to find the number of revolution per minute. So the number of revolution per minute. Just now it's per second. So for per minute, just need to multiply by 60. Just take your omega, multiply by 60. So omega multiply 60 divided by 1 revolutions, it will be 2 pi. Okay, just multiply like this. Then you'll get the answer is 39.0 revolutions. Right? Just write like this will do. Correct into 3 significant figures. So that will be the answer for the question number 1. And now we move on to the question number 2. Okay, now we take a look at question number 2. A light elastic string, so the string is elastic, that will be involving Hooke's law, has natural length A and the modulus of elasticity 4 mg. End of the string is fixed to a point O on the smooth horizontal surface. A particle P of mass m is attached to the other end of the string. The particle P is projected along the surface in the directions of OB. When the length of the string is 5.4 A, the speed is V. When the length of the string is 3/2A, 5/4A, not 5.4. 5/4A, the speed is V, and the length is 3/2A, then the speed is a half V. Find an expressions for V in terms of A and G. So for these questions, I will just draw it like this. This is the original length. This is the O. And then, okay. So this is the original length, A. Then when you extend to 1/5A, which is the total 5/4A, your speed at this part is V. And when you extend to further here, then this part will be 3/2A. Then your speed of the V2 will be the half of the V. Okay, so that is the questions. So what I need to do now is that I just need to show that from here to here, this extension is only 1/4A. And from here to here, this extension is actually half A. Okay, So this will be my x1. This will be my x2. Okay, so for the tension is moving over here. Now for this case, we need to use the conservations of energy, COE. So what we have is the elastic EPE gain, elastic potential energy gain, is equivalent to your KE loss, kinetic energy loss. So the formula for the EPE gain will be a lambda of x2 square minus the x1 square divided by the 2L. The KE loss will be the half m V1 square minus the V2 square. Okay, so this will be the formula. Your lambda is a 4 mg. Your x1, just now we have mentioned x1 is a half a. Your x2 is a 1 over 4a. Your L is a. Your V1 is V square. Your V2 is a half V, so it will be 1 over 4 V square. Cancel the M, cancel the 2. So you will have this simplified. The left-hand side, if you simplify it, you will get 3 over 4 GA. Your right-hand side, if you simplify it, you will get 3 over 4 V square. So from here, you have a V square equal to the GA. That means your V will equal to the square root of GA. Done. That will be the answer for the part A. And move on, part B. Find in terms of G the accelerations of the B when stretched length of the string is, when the stretched length of the string is 3 over 2a. So that means when you stretch until here, what is the accelerations? So according to the Newton's law, okay, so you will be having the, actually is a negative t equal to the ma. The a over here is acceleration, so don't get confused that the a, don't get confused the a and the a here. The a here means length. The a for the tension part is the acceleration. So I think I will use a different symbol. Maybe I will use the x double prime here to represent the accelerations. Okay, so this one is the negative t. Negative t, my t will be the Hooke's law. Just apply the Hooke's law. It will be negative lambda x over the L is equal to the mx is equal to the acceleration. So my lambda is a 4 mg. My x, the extension is actually half a divided by a. So your accelerations will be cancel off. Then you will get this as negative, not negative, negative 2g, negative 2g, yes, correct, negative. Negative means actually, although you are moving in this way, but you are having deceleration because the string is pulling the object P and it will slow it down. Okay, so the negative 2g, that means you are having decelerations actually. So this will be the answer for the part B. And now move on, question number 3. Okay, now question number 3. We have a diagram here. A smooth cylinder is fixed. So the cylinder fixed. So if the cylinder fixed, you no need to consider their weight, no need to consider their normal contact force, anything. Okay, just fix it. So no need to consider the weight of the cylinder. Fixed to a rough horizontal surface with its axis of symmetry horizontal. A uniform rod AB of the length 4A and the weight W rests against the surface of the cylinder. The end A of the rod is in contact with the horizontal surface. The vertical plane containing the rod AB is perpendicular to the axis of cylinder. Okay. Then the point of contact between the rod and the cylinder is C. Okay. Then the AC is 3A. So we know that the AC is 3A. That means this one from here to here, it will be an A. The angle between the rod and the horizontal surface is theta, where the theta is equal to tangent 3/4. So if we do a lot of question already, we know that the meaning for this results or the meaning of this information is actually they expecting us to draw a small triangle like this so that we can form a right angle triangle in order to get sine theta and cos theta in the exact value. Okay, so now the coefficient of frictions between the rod and the horizontal surface is 6/7. Okay, so what I need to do now is, I haven't finished the questions yet. A particle of the weight Kw attached to the rod at B. The rod is about to slip. Okay, the normal reactions between the rod and the cylinder is N. Okay, so the normal contact over here is N. And this is your normal contact here. I call it R. This is the midpoint and the weight is W. The weight is Kw. Okay. And what else? And you should know that this one is 2A. This one is A. And this one is A. Okay. So this one, I think I will erase this. I don't want to make my diagram so complicated. Okay, then we have a frictional force. The frictional force is going this way. It's about to slip. So the frictional force will be reaching the maximum limit. Fr equal to W R. Okay, so the first part of the question, they wanted to show that the N is equals to 8/5W multiplied by 1 plus 2K. So the relationship that we have, we need to, is involving N, involving W and KW. So no R involved. So for this question, definitely we will need to find the moment about the point A. Okay, just find the moment about the point A. So what you need to do now, just to write moment about the point A. So if you take the moment about point A, it will be W 2A cos theta. It will be W 2A cos theta equal to the N3A. Okay, it will be the N3A. Oh, then another one is over here. Okay, so these two are the same. These two are clockwise. Then N is anti-clockwise. So I write wrongly. I supposed to write. I need to give more space for the W. So this one I put N3A is equals to the W of 2A cos theta plus the KW of 4A cos theta. Okay, so you can see that the A can be cancelled. And the cos theta from the diagram over here, you should know that the cos theta is 4/5. Okay, so the diagram need to show, you need to show this diagram in your answer. So this one, I factorize the W, I factorize the 2W out first. Okay, this one I take become 3N. So 2W take out, that means I have a cos theta, which is a 4/5 plus the K, this one 4. If I take a 2 out, then it will be 2 times 4/5. Okay, so this is what I'm having. Then you can see that you can factorize the 4/5 out. You get 8/15 of 1 plus 2K. Oh, there's a W there. There's an N here. I bring the 3 down. So it will be W 1 plus 2K. Shown. Quite straightforward. So 2 marks only. Okay, done for the part A. Now part B. Find the value K. So we have found the moment about the point A. Now we actually usually see that this question got 5 marks, how to find K, and we need to resolving forces. Definitely we need to resolve forces. Usually over here we resolve the forces vertically and resolve the forces horizontally. Okay, so that we will have more equations, solve more unknown. So over here, if you resolve the forces vertically according to the diagram, so this one erase. So this is a theta. Okay, you can see that this is a theta, then this will be a theta. If this is a theta, then this is a theta. Okay, so I just write like this. So if you resolve it vertically, you will have n cos theta. So if you resolve vertically, then it will be involving this. Okay, so r plus n cos theta is equal to w plus kw. Okay, so you have r plus n cos theta is equal to w plus kw. So you have a r plus a 4 over 5n is equals to the 1 plus kw. That is the first equations. However, I do not want the r. So in order to get rid of the r, I will need to resolve the forces horizontally. If you resolve the forces horizontally, you will get Fr is equals to the n sine theta. Fr is a mu r. Sine theta just now refer to the diagram again, the triangle. So you have a 3 over 5n. What is a mu? In the questions, the mu is given as 6 over 7. R you do not know. But from here, you can find that the R can be written as the 7 over 10n. That is your second equations. So obviously 2 into 1. Then you will get 7 over 10n plus the 4 over 5n is equals to the 1 plus k w. Okay, so simplify it. You get 15 over 10n equals to the 1 plus k n. So n will be equals to the 2 over 3 of 1 plus k w. That will be your third equations. Okay, so from the part A, we have that the n is equals to 8 over 15 w of 1 plus 2k. This one I call equation 4. So 3 equal to 4, I'm having that the 2 over 3 of 1 plus k w equal to the 8 over 15 w 1 plus 2k. So the w can be cancelled off and just simplify them. You will get this one as the 5 1 plus k is equals to the 4 of 1 plus 2k. So expand, simplify, 5 plus 5k equal to the 4 plus 8k. So your k will be equals to 1 over 3. Just like that. Done. That will be the answer for the question number 3B. Okay, so move on. We have question number 4. Number 4, a particle of mass 0.5 kg move along horizontal straight line. Its velocity is v meter per second at time t. Second, the forces acting on the force are driving force of 50 Newton and the resistance force of a magnitude 2v square Newton. Initially, the velocity of this particle is 3 meter per second. Find an expressions for v in terms of p. So for this question, if you apply the Newton's second law, resolve the forces horizontally, you will get that it's a driving force minus a resistance force is equal to the net force, MA. So what is your M? 0.5. So 50 minus a 2v square, 0.5 is half. So your A, because we will only want in terms of V and T, so A, I straight away write down it as a dV dt. So I write it down as a dV dt. So from here, I will have this relationship that the dV dt is equal to 100 minus a 4v square. Okay, so in order to find the V, I will need to separate it to the separable variable. This one you can actually just apply the formula booklet MF19. You can apply the formula from the formula booklet MF19. Just search for the corresponding integration result. You can actually direct integrate it. But over here, I do not want to do like that, okay? Because I don't have the formula booklet with me right now. So I just need to do the partial fractions. So if I do the partial fractions, then I will have this become, I take the 4 out first. I think you can see that the 104, they have a common factor of 4. So I make it become 25 minus a v squared. This one I direct integrate. Then I do the partial fractions. I have a 5 minus v, 5 plus v. But if I having like this, then it cannot become a 1. In order to get a 1, you must divide a 10. You must divide a 10. So this one is a 1 over 10, and this one is 1 over 10. Factorize the 1 over 10 out, you get 1 over 40. Integrate 5 minus v plus 1 over 5 plus v. Then I direct integrate it. I will get 1 over 40 of negative ln modulus of 5 minus v plus the ln modulus of 5 plus v equals to the d plus c. Join together, you have a 1 over 40 of ln modulus 5 plus v over the 5 minus v. So the question's giving you the information that initially the v is a 3. That means that when t is a 0, your v is a 3. That will give you c is equals to the 1 over 40 ln 4. Okay, c is a ln 1 over 40 ln 4. So just put it back into these equations. You get a t plus 1 over 40 ln 4. So join together. If you bring it over here, it will become minus. When you have a minus a ln, it will be divide. So it will be dividing this to become 20 minus a 4v equal to t. Now we want to make it become v in terms of t. So I have modulus 5 plus v 20 minus a 4v equal to the e power of 40t. So now we have a modulus over here. We have a modulus over here. So the question is, we should take away when we take away the modulus, should we take 5 plus v over the 20 minus a 4v equals to e power 40t, or we should take 5 plus v over the 20 minus 4v equal to negative e power 40t. Okay, so which one to choose? So in order to make a decision correctly, what you need to do is very simple. Because this is the condition given, you put this condition inside here. Is it fulfilled? Yes, it's fulfilled. But if you put this condition inside here, it doesn't fulfill. So definitely, or you can say that by having a checking in this way, you can decide that the answer is supposed to be when you take away the modulus, it's supposed to be a positive e power 40t, not negative e power 40t. So over here, usually the mark scheme, they never mention that you need to show what is the reason you choose the positive one, but not the negative one. So you can just directly write it down without the modulus, then it will be positive e power 40t. Haven't finished yet. We still need to make it become 20 e power 40t minus the 4v e power 40t. Join together, you have a v of 1 plus 4 e power 40t equal to the 5 of a 4 e power 40t minus a 1. Okay, then your v will be equals to the 5 of the 4 e power 40t minus a 1 divided by the 4 e power 40t plus 1. That will be the answer already. But you can see that these questions, usually they want the power, they want the power to be negative. Okay? But my power over here is positive. Okay, so the reason, usually we want to leave our answer in the form of e power negative 40t. Usually we want to see our answer in this kind of form. So in order to get e power negative 40t, we just, from here, I divide this by e power 40t. I divide the whole denominator over here, also divide it by the e power 40t. Then I will get the answer. So if I divide everyone by e power 40t for the both numerator and the denominator, then I will get this as 4 minus the e power negative 40t divided by the 4 plus the e power negative 40t. So what is the reason? What is the reason we want to leave the answer? Why we prefer negative e power negative 40t? Why we do not want to leave our answer in e power 40t? So the reason is for this kind of questions, usually we will investigate what happened when the d is going infinity. Okay, or we are looking for the maximum speed. So by leaving the answer like this, we actually not able to get the maximum speed. So we will need to deal with these situations. So therefore, we prefer to have this form e power negative 40t. So as you can see that the next questions actually is the one that I mentioned over here. They are requiring you to deduce the limiting value. Okay, we want to find the limiting value. That means just say that when the d is approaching to infinity, then the e power of negative 40t will be approaching 0. Therefore, your v will be approaching the whole thing over here, copy down. Just make the e power negative 40t become 0. So it will be 5, 4 minus 0 over the 4 plus 0. So at the end, you get a 5. That will be the answer for the B. Done. Okay, so move on. Question number 5. Let's take a look at number 5 now. A particle P of the mass M is attached to one end of a light inextensible string of length A. The other end of the string is attached to a fixed point O. The string is held taut with OB horizontal. The particle P is projected vertically downward with the speed of square root of 1 over 3 ag and start to move in a vertical circle. This is a vertical circular motion. P passes through the lowest point of the circle and reaches the point Q, where the OQ makes an angle theta with the downward vertical. At Q, the speed of P is K square root of KAG, and the tension in the string is 11 over 6 mg. Find the value of K, find the value of K and the value of cos theta. Okay, so for these questions, we need a diagram. OP, horizontal, then you're moving vertically down, but we'll move in a circular form, in a vertical circle. And this vertical circle, it will pass through the lowest point, and it will reach to a point called Q, where Q makes an angle theta with the downward vertical. So this is the diagram. At the beginning, your speed is square root of 1 over 3 ag. When you reach to the Q, your speed is K square root of KAG. Okay, so from here, from the diagram, it's very obvious that we need to use conservations of energy. We have the GPE loss equal to the KE gain. So GPE is mgh, KE gain is a half m of the V square minus the U square. Cancel, simplify. Then you get the V square equal to the U square plus 2GH. So what is our H? This is the H. So the H is actually, just need to take A cos theta. H is the A cos theta. From here, A cos theta, you can see that. Just look at this triangle. This is the H. H is the A cos theta. Okay. So now continue. V is square root of KAG. So V square is a KAG equals to the 1 over 3 AG. If you take the U square plus the 2G A cos theta. So all the GA can cancel. All the GA can cancel. Then you have that the cos theta is actually K minus the 1 over 3 divided by 2. That will be my first equation. So after you have deal with the conservation of energy, now we want to resolving forces at Q. At Q, if I resolve the forces towards the center of the circle, so I have a D here. This is the mg, okay, and this is the theta. Okay, so my Q and the theta looks alike. This is a Q. Okay, so don't get confused. So if you're resolving the forces at Q, you will be having D minus mg cos theta equal to the mv square over the A. And the T is given as 11 over 6 mg minus the mg cos theta is equal to the mv square. So by cancel the A, by cancel the m and g, you get 11 over 6 minus the cos theta equal to k. Then you will get cos theta is equals to the 11 over 6 minus the k. That will be your second equation. 1 into equal to 2. So you get k minus 1 over 3 divided 2 is equal to 11 over 6 minus k. K minus 1 over 3 is equal to 11 over 3 minus a 2k. Then you get the 3k is equal to a 4. Therefore, your k is a 4 over 3. The question is looking for k and the cos theta. So from here, from the equation 1, your maybe we look at the equation 2 faster. Okay, equation 2 is faster. So from the equation 2, you have a cos theta is equal to the 11 over 6 minus a 4 over 3. You get 3 over 6 is a half. That will be the answer. Okay, that will be the answer for the part A. Move on. At Q, the particle become detached. So when it's detached, that means it will be projectile motion. It will be projectile motion. So for projectile motions, over here, I think we better draw a diagram. In the subsequent motion, find the greatest height reached by B above the level of the lowest point of the circle. So just now, this is the lowest point. This is the point O. So a point Q, theta, first of all, cos theta equal to half. That means the theta is actually 60 degree. Okay, so at 60 degree, you detach and then you start to move in the projectile motion. So you will reach the maximum distance here. Okay, you will reach the maximum distance here. But at the end, you want to find the distance from here to here. Then when you are detached from the string, then when you move in this way, your V just now was square root of KAG, right? But your V will become your U, okay? Because this is a second stage already. Second stage, the V will become your U. So now it's at the second stage. My V will become the U, square root of KAG. But just now I have found that the K was 4 over 3, right? Okay. Then the theta, we also have the theta is a 60 degree. So at the second stage, we have these two things already. So this information is important for helping us to find the maximum height. So to find the maximum height is involving vertical. So we just consider the vertical component. just consider the vertical component of the projectile motion. So if you consider the vertical component of the projectile motion, then you are having you're having v square equal to the u square plus 2gh. Okay, but over here is minus 2gh. You are going for maximum height. When you reach the maximum height, your v will be a 0. But your u cannot be using the u over here because you are having a vertical component. So it's supposed to be the u sine theta, u sine 60 degree. Okay. So if you consider the vertical component, you're having 0 square equals the u sine 60 degree square minus a 2g, and you will be reaching the maximum height. Okay. So 0. Your u square, it will be a 4 over 3 ag, and then sine 60, it will be 3 over 2 square minus the 2g of maximum height. So just pressing the calculator. So I think I better do it properly. So you get a half ag minus the 2g h max. This is a g, So your over here 4 is actually a 1 only. Calculate wrongly. It's only a ag. So your maximum height is equal to the half a. But the height, the total height is the maximum height plus this height. So what is the second height over here? This one. Just now, this one is a cos theta, right? So what is the height here? This one, the height will be a minus the a cos theta plus the h max. So a 1 minus the half plus half a. At the end, you get an a. That will be the maximum height that that above the lowest point of the circle. Okay, so this will be the answer for the question number 5. Move on. Question number 6. Okay, now we take a look at question number 6. You have two uniform smooth sphere A and B of equal radii, have masses m and km respectively. The two spheres are moving on a horizontal surface with speed u and 5 over 8 u respectively. Immediately before the sphere collides, A is traveling along the line of center B, and B is and B directions of motion makes an angle alpha with the line of center. C diagram. The coefficients of restitution between the sphere is 2 over 3 and tangent alpha is 3 over 4. Okay. So for this question, actually, everything is in the diagram already. However, we need to do something with this result. Okay. So first of all, we start from the tangent alpha equal to 3 over 4. And we should know that this is usually we can draw a small right angle triangle here. Put the 3 here, put the 4 here, then you get a 5 using Pythagoras theorem. So over here, we will have to resolving the forces before and after. So before and after. Before the collision, A is moving this way and it's called U. Then B is moving this way. And this is the alpha. This is the 5 over 8 u. Okay, 5 over 8 u. After. So for A, after the collision, I assume that A is still moving horizontal, either going this way or going this way only. Okay. Cannot going slanted because you are moving horizontal at the beginning. So after you collide, it will also moving horizontal, either continue in the same direction or reverse the direction. So over here, I assume that the A going this way, continue with the same directions. But the B, according to the question, they say that after the collision, the B is perpendicular to the line of the center. So the B is like this. So this situation is actually kind of simple. Now, we consider we want to find the value K. So we consider the horizontal motion first. If we consider the horizontal motion, we need to apply the conservations of momentum. Okay, conservation of momentum. So you have this is a M, this is a M, this is a Km, this is a Km. So conservation of momentum is Mu plus the Km negative 5/8 U cos alpha equal to the MVA plus the Km of 0, because the VB only have vertical motion, don't have horizontal motion, so just have 0. Okay, then you can see that M and M and M can be cancelled. You have a U minus a 5/8K. Your cos alpha, just from here, you can see the cos alpha is a 4/5. So it will be 4/5 equal to the VA. Then you have a VA is equals to the U of 1 minus half of the K. That will be my first equation. Then after you use the conservations of momentum, you can now apply the Newton experimental law or the law of restitution. So the Newton experimental law says that the E is equal to the negative of the VB minus a VA. So over here, not VB is a no horizontal motion, so it will be 0 minus a VA divided by the negative 5/8 U cos alpha minus the U. Just a formula. So what is your E? E is given as 2/3. Then this negative I cancel with the denominator. Then I'm having VA, negative VA is equals to the 5/8 U cos alpha is a 4/5 again, plus the U. So you're having a VA joined together, you get negative VA is equal to the 2/3 multiplied by the 3/2U. So you get the VA is a negative U. So the negative over here means the direction reverse. So my assumption just now was wrong, okay? But it's okay. If you make an assumption in the wrong direction, doesn't matter, because the calculation shows to you that it has reverse, then it's fine. No problem, not a problem. So we can just write VA as a negative U. Okay, but we haven't find the K yet, okay? So this one is a second equation. So to continue over here, 2 into 1. So 2 into 1, then you are having negative U equals to the U of 1 minus the half K. Cancel the U, then you will get half K equal to 2. Therefore, your K is a 4. Done. Okay, so then we go to the part B. We want to find the KE loss of the total KE as the result of the collision. So we need to find the VB. In order to get the total energy loss, KE loss, we need to find the VB. So we have considered the horizontal motion at the very beginning, but we haven't considered the vertical motion, vertical component. So the vertical component is, you can see that for the VB, it will be equal to this. So the VB is equal to the 5/8U sine alpha. Just do like this. VB is equal to the 5/8U sine alpha. Because the vertical component, it doesn't involve in collision. So just before and after are the same. So sine alpha is a 3/5. Then you get 3/8U. Okay, now we are ready. to do the KE initial is a half m u square plus the half km of a 5/8 u square. Okay, so this one take the mu square out. This one is a half plus, maybe we can take the half out as well. Okay, take the half out. K is what? K just now is a 4. So 4 multiplied by 25/64. So this one need calculator. Okay, 25 times 4/64 plus 1, then divide 2. Convert into the fraction 41/32 mu square. What is your final? KE final will be the half m, also u square, but this is a negative u. To be more precise, it's actually a negative u. Plus the half, maybe we can write 4 already here. Then the last one is a VB square. VB square is 3/8 square. 3/8 u square. So take the half m u square out. You get a 1 plus the 4 times 9/64. Okay. 36 divide 64 plus 1 divide 2. 25/32 mu square. So the total KE loss, total of KE loss is equal to the KE initial minus the KE final. So this one, it will be 41/32 mu square minus the 25/32 mu square. You get a half mu square. Done. That will be the answer for the B. Okay. And we have a question number 7. Okay, now we take a look at question number 7. A particle P is projected with speed v meter per second at an angle 75 degrees above the horizontal from a point O on the horizontal plane. It then moves freely under gravity. Show that the total time of flight in second is 2v/g multiplied by sine 75 degrees. So for these questions, what you need to do is, in order to find the total time, usually we will consider the vertical component of the motion. It will be y equals to the v sine 75 degree t minus a half g t square. So when y equal to 0, then you are having 0 equal to t, v sine 75 degree minus the half gt. Then the t is equal to 0 and the t is equal to the 2v sine 75 degree over the g. This one ignore. Then this one shown. Okay, so the reason is that this projectile motion is starting from here is t equal to 0. Then when you reach until here, your t will be the 2v sine 75 degree over g. Okay, so that is the reason we ignore t equal to 0. So you can see that this time, the time of flight is actually depends on the vertical motion. It depends on the vertical motion. Then B, a small vertical barrier is now inserted with its lower end on the plane at a distance of 15 meters from O. The particle is projected as before, but now strikes the barrier, rebounds, and return to O. the coefficients of restitution between the barrier and the particle is 3/5. So that means if you consider the diagram, there's a barrier here from O, 15 meter from O. And when you do the project, when you try to project the particle, it will hit the barrier, and after that, it will rebound back. Okay, so for this case, we need to explain why the total time of the flight is unchanged. So over here, if you look at the motion, right before you hit the barrier, this one is involving the collision. So right before you hit the barrier, you are moving in this way. You're moving in this way. Okay, let's say this is a V. Okay, let's say maybe we call this one U lah. This angle, maybe this angle is alpha. Okay, so the collision before and after it will go like this. After you hit the barrier, then it will go like this. Then this will be an angle beta. So the collisions over here is only involving the horizontal component. For the vertical component, it's still the same before and after. Okay, when you look at the speed of the particle before the collision and after the collision, if you look at the vertical component of the speed before and after, it's actually the same. But it's just that for the horizontal speed, the horizontal component of the speed of the velocity before and after are different. So for the horizontal, for the one that is perpendicular to the barrier, the before and after, it will be involving Newton's experimental law. But for the one that is parallel to the barrier, before and after, the value are the same. So for this case, it will not going to affect the total time, because the total time of the flight is actually depends on the vertical component. Remember just now I mentioned that the total time of the motion is involving on the vertical component. So therefore, the total time of flight is unchanged. So what you need to do, just to mention that the total time of the flight is unchanged because of the vertical. Okay, just say that the total time of flight is unchanged because of what? Because of the vertical component of the velocity is unchanged. Okay, like what I mentioned, before and after. Before and after. Before is U, after is V. Okay, this is alpha, this is beta, then the vertical component of the velocity before and after is unchanged because it's not involving collision for the vertical component. Okay, so the diagram is not needed. No need to provide a diagram. Just mention that the keyword is that the vertical component of the velocity is unchanged. That's all. So that is the answer for the B. Only 1 mark. Then C, find an expression for V in terms of G. So in order to find the expression for V in terms of G, so over here, we need to find the horizontal component first. X is equals to the V cos 75 degree T. Okay, so because the collision happened at 15 meter away from the O. So this is the horizontal displacement. So we were going to have x is equal to 15. So if x equal to 15, then the time that you are having collision is called t1. So the t1 is equal to the 15 over the v cos 75 degree. That is a t1. Okay, now we want to find t2 is after the collision. After the collision, what happened? But before we find the time t2 for the time travel after the collision, we need to find the velocity right after the collision. So we just use the Newton experimental law. We have a E equals to the W over the V. Okay, but the W over the V is supposed to be V cos 75 degree. I cannot use V anymore because the V already involved in the given questions. The question already give you the V for the velocity. So the velocity after the collision, I will use W. Okay, so the W will equal to the EV cos 75 degree. Okay, then after the collision, you also have X equals to the W. You're going to have a W D2. W D2. So your X is still 15. Your W is a EV cos 75 degree D2. Okay, then your D2 will be the 15 of the EV cos 75 degree. So do aware that this and this are the same. So we can actually write this one down as, I can write the D2. Oh, by the way, what is the E? I forgot to write down the E. The question for the E is 3 over 5, right? Okay, the question given that the E is 3 over 5. So I think I better write 3 over 5. It will be better if I change the E become 3 over 5. Three over 5. So this one, you can write this as 5 over 3 of the D1. Okay, that is your D2 value. Now, given that, no need given because from part 2, we know that the total time is the same. So the total time T is equal to T1 plus T2. Okay, so the T is given as the value just now. This is the total time of the travel, of the particle travel. So therefore, you have 2V sine 75 degree over G is equal to the D1 plus the 5 over 3 D1. So you will get this one as a 8 over 3 D1. What is D1? D1 is this value. D1 is this value. So you will get this D1 as a 15 over the V cos 75. Okay. So now what you need to do now is you just need to make sure that we try to get rid of the denominator, or we try to consolidate all the V together. So you have a 2V sine 75 multiplied by the V cos 75 is equals to the 40G, equal to the 40G. And we know that we have a V square sine 150 degree. This one is a double angle formula. 2 sine theta cos theta equal to the sine 2 theta. So the 75 degree will be multiplied by 2, then you get 150 degree. Okay. then it's equals to the 40G. Sine 150 is a half. So V square is a 80G. Then your V is equal to the square root of 80G. Simplify it, then you get the 4/5G. That is your speed in terms of G. Just like that, done. So this will be the answer for the question C. And this will be the last part of the questions, no more. So we stop the video here.